Today, I am going to focus on the communication aspect of politics and the focus on communication in the discipline of computational politics. So the starting point is the idea of politics as what do we think when we think about politics? Well, I think about decision-making processes, and the idea is to have methods for cooperating. I think about negotiation, conflict resolution, or even producing conflict, win and between groups. And all these things are centered around communication actions. All sorts of political activities, the communication of thoughts, the political behavior that is intended to obtain some results goes through communication. So communication is central in all activities that are around politics. In all these different ways in which communication is playing an important role in politics, we can, however, identify different ways in which communication is used. So I can call this, I will call this different ways, different patterns of communication, because they are different in the way communication is used between individuals. So one of them is communication for group decision-making. You can think about individuals that are communicating with one another to, for example, achieve decisions or exchange information. And this is the typical communication in grassroots movements or in social media, and it happens peer-to-peer. This kind of communication is used, for example, with public consultations when governments or policymakers want to know opinions of people. It is exploited in participatory systems for policymaking, and sometimes it's trying to it becomes central in systems like liquid democracy or systems that are based on deliberation platforms. Another pattern for communication is what we may call broadcasting, and this is the typical object of study of political communication studies. So here you have the politician, for example, that sends a message to convince, for example, audiences to go in one direction or another one. We can find this in political campaigns. This can be used for propaganda, for self-promotion, even not necessarily politicians, but even influencers or middle people who are repeating messages from a politician. This can also be considered broadcasting. Even in election debates, when different candidates for roles of responsibility are debating in the television, for example. In fact, they're not trying to convince each other, but they're trying to convince audiences. So all these kind of patterns are in a way a form of broadcasting, and they're not all negative, of course, like in the case of propaganda, but they can also be positive. So politicians may need to raise awareness on topics. We can think of methods for fighting misinformation, communication for reducing bias, and so on and so forth. So in when thinking about communication at these levels, the main question that I would like to address is, when is communication beneficial? If we think about communication from an evolutionary viewpoint, the fact that we communicate and that communication is central in society is this is because communication is beneficial, and otherwise, from an evolutionary point, communication would have disappeared, right? So one important proposition that takes this perspective, that was proposed about 10 years ago, is the argumentative theory of reasoning by Mercier and Sperber, who even posit that reasoning in humans has evolved for public purposes, for the purposes of persuading each other to negotiate and assess communication. And this is an interesting idea, because the reason itself is born out of the need of supporting communication. And in all this, a central role of being able to communicate in a good way is the role of argumentation. So argumentation is what I'm going to talk about, because I believe that argumentation could be an important way of modeling communication and supporting communication in computational politics. So argumentation theories, the whole idea of my contribution is that argumentation theories are a powerful tool for understanding political communication and explaining the dynamics of opinions in politics. And this is for the two types of patterns of communication that we have considered. For example, for decision-making processes, argumentation is one way of modeling decision-making processes, for example, by showing how arguments can be evaluated, exchanged, and selected eventually. From the viewpoint of broadcasting processes, argumentation could be a way to understand political communication, analyze political communication, improve it, and how to better benefit from communication, for example, by filtering out arguments that are not valid, for example. This whole kind of studies have a long history in communication and political studies. So argumentation has been studied since thousands of years. However, recently in computer science and artificial intelligence, argumentation has become a central area of study in a sub-area of artificial intelligence that is called computational argumentation, which is about using artificial intelligence methods to support various tasks in around argumentation. So argument identification, for example, analysis, evaluation, and invention. So argument identification is about identifying arguments from speech, from discourse, for example. Analysis is about understanding what is the function of arguments, how arguments relate to one another, and what arguments are implied, what are missing parts of arguments, for example. Evaluation is more about understanding which arguments win, which arguments are consistent with one another. And invention is more about filling in the gaps or creating arguments anew. All argumentation theories are based on argument models. This is well known, and it is not only related to computational argumentation. For example, in one of the most famous argument models is Toulmin's model, which I'm sure that most of people in this audience know very well. In computational argumentation as well, the studies are heavily relying on models, on argument models. So the idea is to formalize argumentation models and to adopt them as an underlying framework to operationalize various reasoning tasks. So for example, take a simple model, which is the abstract argument model. The abstract argument model is basically abstracting away from any possible content or structure of the argument. So anything is an argument. Anything, when I say anything, I really mean anything in the sense that what remains in an abstract argument model is a series of entities, abstract entities, and the whole focus is on which entities attack each other. So the focus here is on the relations, in particular attack relations between arguments, and in the figure, in the example that I have drawn, one argument is attacking other arguments, and therefore there is the idea of arguments that are defeated and arguments that instead survive. So the idea is here to figure which arguments win in a sort of conflict calculus. This simple idea has given rise to a number of different lines of work in artificial intelligence in the last decades, and has become a large area of knowledge representation. But this is not the only one. Other studies use more structured representations of arguments. For example, one which is very popular because it is simple, but at the same time it gives some structure, is arguments as evidence connected with claims. So an argument is a premise or some evidence, a link that connects evidence with the claim and the claim. What kind of tasks can we address with computational argumentation? One of them is argument analysis. Argument analysis is about formalizing arguments in a sort of a structured way. Here you can see an example with drawn with a tool which used to be rather popular called Orocaria, and you can see that it is possible to isolate some argumentation schemes and connect them with one another, and then reason about the overall arguments that are in play. A very popular tool among analysts is argument diagramming. This kind of methods and tools have been used in areas that are related to computational politics. For example, in a number of proposals, some colleagues from the Knowledge Media Institute at the Open University, particularly Anna Deliddo and others, have been developing platforms for group decision making that are based on argumentation. So argumentation and argument analysis and diagramming, and you can see a number of them if you search. One of them, for example, is the Debate Hub, but there are many more. And the idea is to improve communication, grassroots, let's say, communication, peer-to-peer communication by using argumentation. And this is one way in which computational argumentation can be interesting for computational politics. Another task is argument identification, or more in general, argument mining. So argument mining is about identifying arguments from text or from speech, and it is a more and more popular sub-area of natural language processing. And nowadays it has grown a lot, so it is not restricted anymore to argument identification, but it has diversified in a number of sub-tasks like argument retrieval and ranking from big sources of text like Wikipedia, or like blogs, or like, you know, all kinds of social media, argument clustering by trying to summarize large discussion into a few key points, argument analysis by trying to reconstruct, for example, implicit claims, or analyzing how persuasive or convincing arguments are, all automatically, okay? And even argument invention recently by argument generation and summarization. So one simple conceptual pipeline for argument mining is this one, and I'm showing this to illustrate a possible process of argument mining. You start from the text, and then you detect in the text what are argumentative discourse units, let's say, or argument components. So you identify in the text what sentences contain arguments, and then inside those sentences you try to identify what segments contain claims or evidence, and then you connect them together to reconstruct the whole argumentation in what is called argument structure prediction. This is an example. Take Wikipedia text about immigration, for example. Then one first step is to identify what are claims in the text, and then another step is to identify what is evidence. Evidence, as you see, is according to Article 13 and so on and so forth, and or some data coming from statistics or from demographics. And then subsequently you can use these bits and pieces in order to reconstruct different claims or different arguments and relations among arguments in the text. Okay, so this is the argument mining process, and at least some of the basic steps of argument mining. How can argument mining help computational politics? For example, you can use it to do some analysis of political discourse. And this afternoon, Serena Villata will talk about work, very, very interesting work she did recently in this in this domain. And this can be used, for example, to support political science analysis at a scale. Another possibility is using argument mining for to create tools for improving communication. And this, you know, comes with a question mark, because it's a good idea, but it is not. There is no evidence that this will work, of course. In any case, the idea is to integrate some argument mining tools into social media platforms, discussion forums, for example, in order to help quality content emerge in these kind of discussions. So help inform discussions and address misinformation, for example, and offer different perspectives. In a similar way as it was presented before, when the idea was to escape from filter bubbles. Now, in the few minutes that are left, I would like to to briefly mention 3 different experiments that we've been doing with our group in the last years that involved uses of computational argumentation in the domain of computational politics. So the first one is an experiment made by using abstract argumentation. So the first simple model of computational argumentation I presented before. So abstract argumentation in order to model the mind of hypothetical, people, so agents. The idea is to construct an agent-based model where agents represent people in the society or, stylized people in the society that are connected following some topology. This topology, for example, is called the connected caveman graph, where there are some clusters of people and there are some weak ties between clusters. And the idea is, can we explain or can we model the diffusion of opinions in this kind of networks by representing not only the opinion of people, like in classic studies, where people are thinking in favor or against, for example, some policy, or they are left or right, or they are more or less in favor of some position. But instead of going in a -1 +1 scale, for example, we have instead an argumentation framework where different arguments are attacking one another, and the interaction between people is about convincing each other that one attack is stronger than the other, one argument is stronger than the other, and persuading each other. So can we use this kind of model to show how polarization evolves, what is the role of weak ties, and how opinions spread in the networks. So this was one experiment. Another one was using argumentation frameworks and formal argumentation in order to augment the syntax that can be used by people, for example, when using Twitter. So Twitter is based on hashtags. So besides hashtags, we have proposed 2 different new symbols, which are one for representing arguments and the other one for representing attacks among arguments. So in this experiment, we developed an app for having people communicate with Twitter and then having discussion where they can exchange messages, and the system, the app is able to process this data and create some visual representation of the ongoing debate in the hope of showing arguments, showing a summary of the discussion, and showing what positions are agreeing with one another, which ones are winning, which ones have more support. We did experiments using this kind of tool in a variety of situations. Probably the most interesting one was involving a class of political science students following an election debate by European Parliament candidates, and students would kind of exchange their views on the debate by using this tool. Last experience was to use argument mining for the analysis of televised debates. in a number of different experiments, we have studied, for example, this one is about UK Parliament debates with Clegg, Miliband, and others. The idea is, can we use audio signals together with text signals in order to have a better analysis of what is being said, and to understand what is the role of audio features, what is the role of paralinguistic features and communications, and to understand argumentation at not only at the textual level, but also at multimodal level. So these are some examples of what we have been doing. So to conclude, I would like to give you my final thoughts. So I think that argumentation is central in social life at all levels, both at the person-to-person level, but also at the bigger level and political level. Computational argumentation in all its different formats could be a very effective way of supporting computational politics tasks such as political analysis, and the idea here to go beyond sentiment analysis and beyond, the study of polarization, but to go more in the perspective of the last talk, where a multidimensional space was explored. Here, the various dimensions would be the arguments. And another task is improving public deliberation and e-participation. I have to say that not all the experiments were successful. For example, one thing we learned from micro debates was that whenever you ask users to use some syntax or some other form of communication, which is a tiny bit away from natural language, then this may help, but this may also create some barriers. The experiment with the agent-based modeling taught us that abstract argumentation may not be enough, and structure in arguments is important if you want to have a meaningful model. And it also taught us that the validation of models could be challenging. I think it is not only when you use argumentation, but when you use agent-based models in general. However, and to conclude, I want to give like a positive message. I believe that rapid advancements in argumentation mining and NLP in general could create promising scenario for computational politics, and especially for argumentation-based computational politics. One of the interesting directions that I see for the future is multimodal analysis, where we go beyond text and image, but we can consider also other kind of inputs. Okay, sorry for being long.
Thank you very much, Paolo. You weren't long, and also it was very interesting. Are there any questions from the audience?
I have a question.
Yes, please.
So I want to talk a little bit about motive-defined argumentation. So you mentioned arguments can be looked at from an abstract point of view, and then, for example, two different issues can be there can be factors in one issue that can relate to questions in the other issue, and then in the context of like motive-defined argumentation, a person would sort of be happy once they look at a few factors that can affect these two issues, and then just make like the decision based on a few variables that they have access to. In this setup, I feel like the person might ignore consequences from these decisions that might be because of like finding these commonalities between them. So is there a framework to sort of analyze these hidden covariates that can affect the issues in specific because they were looked at from a more abstract point of view?
I'm not sure I entirely understand the question. However, you know, the idea of abstract argumentation is that you use a formalism to model a debate. So the model is made by hand. So experts will decide how to model a debate using abstract arguments, and that's what we did. For example, we took some ongoing discussions, some text, and we constructed by hand some argumentation frameworks like these ones to give an abstract representation of the thing. So it is up to the modeler to decide when two arguments are the same or when they are different and how they relate to one another. So it is a manual activity. On the other hand, the idea of argument mining is to automatize the process. And then, you know, all sorts of questions about similarities, correlations, you know, between arguments arise and are addressed in this kind of domain. The two different lines of work, so computational argumentation from the perspective of reasoning, like in abstract argumentation, and argument mining, so the perspective of NLP, are not yet merged together. So it is a matter of future research to put all these things together in a single pipeline. So what is happening here, it is still some theoretical objective, let's say. We're not there yet. I don't know if I addressed your question.
I think so. I have one follow-up for this. So in the context of like, I want to take maybe forest fires as an example. California had a lot of wildfires in maybe the last 3 or 4 years. And there have been reports about like the Amazonian rainforests burning at a rate that is more than it has been before. So like clearly the common part is like the forests burning. So if I were to look at this from an abstract argumentation point of view, like I want to understand what type of similarities are considered good similarities in terms of like trying to analyze common parts between them. So is this like a good problem to look at from this theory point of view?
You know, when you talk about abstract argumentation, you lose all the notion of similarity because abstract arguments are abstract. So when you have, so here, claim 1, evidence 4, so the fact that evidence 4 supports claim 1 is exactly the same structure as evidence 2 supports claim 3. So from this viewpoint, although claim 1 and claim 3 are completely different, the two structures are identical. So there is no notion of similarity here. When you study abstract argumentation, what you study is that this kind of abstract structure, if you interpret it as an argument, that these are arguments and the arrow is an attack relation, what you conclude is that there is a defeated argument here. The content is not relevant. So there is no notion of similarity here. The notion of similarity instead comes when you are thinking about argument mining. So when you work on the text, then, of course, there are all sorts of methods to understand when two arguments are similar, or when two claims are the same, or when arguments are related, or when arguments are in conflict.
I
this is
understand. Thank you.
separated from abstract argumentation. Abstract argumentation starts from the assumption that you do not care about content.
Thank you.
Okay, thanks. Thanks for the question.
So thank you very much again, Professor Toroni.
Thank you, Yanni.
And